We will continue. Rate of reaction. What is the rate of reaction? How to write the rate of reaction of various chemical reactions? Simply change of concentration per unit time. You must be knowing that the speed of an automobile is expressed in terms of change in position of distance covered by it in a certain period of time. Similarly, rate of chemical reaction is measured. The rate of chemical reaction is a measure of the speed with which the reactants are converted into product. Then the speed is called rate of reaction. The chemical reaction is a measure of the speed with which the reactants can be converted into product. The rate of reaction is defined as the concentration of reactant, decrease in the concentration of reactant per unit time, decrease in the concentration of reactant per unit time, or increase in the concentration of product per unit time is called rate of reaction. What is the statement? Simply R is equal to minus d by dt of concentration of X, means plus or minus, or minus d by dt of concentration of R. R means reactant converted into product, R is equal to plus d by dt of concentration of product. Decrease in the concentration of the rate of reaction is defined as the decrease in the concentration of reactant per unit time, or increase in the concentration of product per unit time is called rate of reaction. Simply plus or minus dx by dt, change of concentration by change in time is also called rate of reaction. For example, now I am taking an hypothetical equation here. For example, if you take a hypothetical equation, R gives rise to product, okay, in which 1 mole of reactant produces 1 mole of product P. The rate of reaction may be expressed either the following two ways. The rate of disappearance of decrease in the concentration of reactant per unit time, that the rate of reaction decrease in the concentration of reactant per unit time, or increase in the concentration of product per unit time. Simply there are two ways are there. The rate of disappearance of the rate of disappearance of decrease in the concentration of reactant per unit time. Second one, the rate of appearance, increase in the concentration of product per unit time. For example, now I am taking here concentration of R1, concentration of R2 are the reactants, concentration of product P1, concentration of product P2. Their changes. Okay, delta T is nothing but Tt is equal to T2 minus T1. R is equal to minus R2 minus R1 by T2 minus T1. R is equal to plus P2 minus P1 by T2 minus T1. It is equal to simply change of concentration. R is equal to minus dr by dt, R plus d concentration P by dt. This is the decrease in the concentration or increase in the concentration of product per unit time. So what are the units of rate of reaction, sir? Units of rate of reaction, that is equal to change in concentration by change in time. Change in concentration by change in time. That is equal to mole per liter per time, or it is also mole liter inverse, either second inverse or minutes inverse. So if you take for gaseous, if you take for gaseous phase, this is aqueous phase. For gaseous phase, this is for aqueous phase, means liquid form. For gaseous phase, the units of rate of reaction atm by time or atm by second. atm per second. These are the units. The relationship between different species, rate of different species. Relationship between rate of different species. Different species means the reactant species, reactants and products in the chemical reaction. Consider a general reaction. Now I am taking a general reaction. Small a moles, small b moles. Now I am taking one general reaction. Time, initial time is equal to 0. Their concentration A here 0. After some time, the concentration can be reduced to here bx. After some time. Now, rate with respect to A. Rate of A is nothing but minus d by dt of concentration of A. Here, you can observe here, minus d by dt of A means so initial concentration of minus, here initial concentration, final concentration. Minus d by dt of A minus x minus of A. Plus A minus A gets cancelled. Minus d by dt of x is there. That is equal to here ax a minus ax, here minus a, minus of minus plus minus ax minus x, minus a here, minus a plus a gets cancelled, minus of minus plus d by dt of ax. Here rate of a is nothing but minus d by dt of concentration of a is equal to dx by dt, a transposing this side, minus 1 by a. This is equation a with respect to a. If you take with respect to b, rate of reaction of b is equal to plus d by dt of concentration of b, plus d by dt of concentration of b is nothing but bx minus 0, that is bx. This is equal to plus d by dt of concentration b, plus b transposing, that's 1 by b, d by dt of concentration of b is equal to dx by dt, equation 2. From equation 1 and 2, rate is equal to minus 1 by a d by dt of concentration of a is equal to plus 1 by b d by dt of concentration of b. Okay, this is the mathematical expression of rate of reaction. Rate of reaction. I hope it is clear how to write the rate of reaction of various reactions. Now I will write some example of rate of reactions. For example, N2 plus 3H2 gives rise to 2NH3. What is the rate of reaction? Decrease in the concentration minus d by dt of concentration of N2 is equal to minus 1 by 3. Here number of moles 1 by A means minus 1 by 3 d by dt of concentration of H2 plus 1 by 2 d by dt of concentration of NH3. Okay, these coefficients written on the by. If you take one more example, 2a plus 5b gives rise to 6c. What is the rate of reaction here? Minus 1 by 2 d by dt of concentration of is equal to minus 1 by 5 d by dt of concentration of b is equal to plus 1 by 6 d by dt of concentration of c. Like that, we should write any chemical reaction. H2 plus O2 gives rise to 2H2O. R is equal to minus 1 by 2 d by dt of concentration of H2 is equal to minus d by dt of concentration of O2 plus 1 by 2 d by dt of concentration of H2O. These are the various examples of rate of reaction. How to write the rate of reaction. Now graphs here. The graph between rate of reactions. Okay, now I am taking, this is the time. This is concentration of reactant on y-axis. Okay, decrease in the concentration of reactant per unit time. Or if you take product, increase in the concentration of product with time. These are the graphical representations. Okay, rate is inversely proportional to the time. You take rate inversely proportional. One more graph. Okay, this is time. Okay, this is the rate. These two are inversely proportional. Decrease in the concentration of reactant. These are the graphs. Next, last concept in this part. Instantaneous rate to average rate. Instantaneous rate. Second one is average rate. What is instantaneous rate, sir? The rate is measured at a particular instant. The rate is measured at a particular rate. At a particular rate. It is obtained by drawing tangent. And it is obtained by drawing tangent. By drawing tangent at the time. By drawing tangent at the time. It is called instantaneous rate. Instantaneous means particular rate. Now I am taking here graph. This is x-axis, this is y-axis. Now I am taking concentration of reactant. Here different time. Increase in the concentration of reactant. Instantaneous, particular instant. If you take here, this is concentration of R0. Okay, here concentration of R1, concentration of R2, particular instant, that is here T2, T1, here T0. Minus d by dt of concentration of R. This is the graph instantaneous rate. To take average rate, the rate is measured concentration of product to time. The rate is measured over a finite interval of a time, and it is obtained by knowing concentration of the substances at a different timings. It is called average rate. What is average rate? The rate is measured. The rate is, second one is average rate. Average rate. The rate is measured over a finite interval of a time, and it is obtained knowing concentration of the substance at two different times. It's called average rate. Thank you.